So in Kotlin, there is another type of class called data class. So data class, as the name implies, is a simple class. All it does is to hold data. So there's no concerns about trying to inherit to make it special in any way. So the main use is just to hold data. For instance, if we want to create a class called person, right, that will create person objects, we can just create that class as such. Say data class like this and pass a name, and I can say person and pass, of course, the primary constructor. I can pass here val name, going to be a string type, or I can say val last name, and it's also going to be a string. And also I can continue and say I want age to be an integer, and I don't have to even create a body for this class. So now, inside of main or anywhere else, I can just go ahead and say val person is equal to person as such. And of course, I can go ahead and initialize this person. Put a new line. I'm going to say name. It's going to be Joe. Last name, Paul. And age, 23, right? And now I can say print ln person as such. If I run this, we're going to see that person now is in this format. Because this is a data class, that means when Kotlin compile this, it's going to just have some standard functionality and some utility functions that are automatically given to this data class. In fact, if I come here and I say person to access the variable, you can see that we have copy, we have equals, hash code. So it just derives a few of the functions that a normal class would have. And this toString here is of course added as well. That's the reason why whenever we say print just person, you can see the representation that it has. It says person, name is going to be equal to Joe, last name Ball, age 23. In many cases, this is how actually you will see this class being used or created in Kotlin. Something that is simple, and it's going to just hold a data, in this case a data person like this. Then you just go straight and do that. And with this you can do all sort of things, right? I can create as many persons as I want. So I can, for instance, say val list of people is equal to list of, this is indeed an immutable list, so I can say person, that we create a person first, and I can go ahead and create another person right away inside here and pass the name Ruti and last name Mashava, continue age 54. Copy this and create another one, or I can just do what we did before, val Aroni is equal to that person there, and I can come down here and say val Ruti is going to be equal to this person. I could have done this as well, of course, just passing like that, but this is way better and looks better. So I can pass here Aroni object and Ruti like that. All right, so there we go. So we have this simple list containing person types. So I can of course say list of and invoke the for each, for example. Remember that lambda. And for each person that I get, I can say print ln like that. I'm going to print this person in form of it, right? It's a person type. The other thing we can do, we can change this it to something more readable. I can say person and add, of course, the arrow. Okay, this is a lambda. So person, then it's going to be the object person. With the person, I can invoke .age like this. So if I run, we can get all of the ages. So 23, 54, 54. Looks like it doesn't like this. Shadow it. Okay, we can just change this to a different name. Let's say item, and then we're gonna change that, of course, like this. The problem we were having is that it was being shadowed by this person that we had created there. So trying to get just unique variables. All right, this is going to work still. We can run this. We can see now we have the same results. All right, so whenever you want to just create a class that it doesn't need much, all it needs to do is to hold data, such as this one here. You just append data, say data class and the class name, and pass in the primary constructor, pass all of these parameters here, which are the fields been created and set up.